Okay, two polygons are selected at random from a group consisting of a non-isosceles trapezoid, which is this one, an isosceles trapezoid, which is here, and a parallelogram. Find the probability that both polygons have two pairs of congruent angles. So this is what we're looking for, two pairs of congruent angles. So that's the first thing that we have to do. We have to look at our figures and we have to say, okay, which of these three figures even has two pairs of congruent angles? Well, the trapezoid doesn't, but the isosceles trapezoid does. It has one pair here that are congruent to each other and another pair here that are congruent to each other. As well, the parallelogram. Here's one pair here that are congruent to each other, and here's another pair here that are congruent to each other. So those are our figures. So there's two out of the three figures that have what we're looking for. But the way that we want to do the probability, they're asking us, they're saying that two polygons are selected, and they want to know what the probability that both of them have these characteristics. Well, what we usually do is we say, okay, to set this up, we let x equal the number that we're looking for. So x is, I'm just going to make it short and say x is the number of polygons that we want. And what we want is this up here, two pairs of congruent angles. So when they ask for the probability of something, you usually say, okay, well, the probability that x, the number of polygons that we want, equals 2, that probability is equal to the probability on our first choice. There's 3 to choose from, but only 2 out of the 3 have what we want. So there's a 2 out of 3 chance of getting what we want the first time we pick. Then for our second pick, we multiply this probability by what's left over. Well, what would be left over? Say the first pick we chose, say we chose this parallelogram. So then what's left over are only 2 figures. And out of those 2 figures, one of them is what we want. Remember, we're taking the probability of what we want here. So what's left over of what we want then is just 1 out of the 2, because the one that's left is the isosceles, say, for instance. So 1 out of 2. So then we multiply those probabilities to get the total probability of both of them being chosen. And that's going to be a smaller probability than each of these 2 separately. And that would make sense. To have both of them chosen should be a smaller probability than just one or the other probability. So let's see if that's true. Well, we have 2 times 1 is 2, and 3 times 2 is 6. Well, that reduces to 1/3. And so that's the probability then of getting both polygons if you chose 2 out of the 3. And like I was saying, 1/3 is smaller than 2/3, than just picking one of them, and 1/3 is smaller than 1/2, than picking, just the 1 out of the 2. So you can see that it should make sense that it is a smaller probability to have both of them rather than one separately. Because sometimes in probability, people always get confused because they don't know if we're supposed to multiply the two fractions or if we're supposed to add them or if we're supposed to do counting. For this particular probability question, there was no counting involved because with counting, you generally have to find different ways of arranging things, and that's not what we're doing in this problem. There are problems like that, and I can do a video on that, and I actually did one with my student here. We were talking about angles, and we were combining different ways that you could combine supplementary angles, and that involved counting. That's a completely different way of solving a probability problem. So for this one, we don't add or anything. When you add probabilities, it's usually because they're asking for the word, they're asking for probability of at least, let's see, let me rephrase that. Probability of x, say greater than 3 or something like that, or probability that x is less than 3 or something like that. Generally, when something is the probability, when x is supposed to be greater than a number, you generally do a 1 minus the probability of x equaling 1 plus the probability of x equaling 2 plus the probability, well, that's greater than or equal. So then that would be it. It would be 1 minus that probability. So that's where you use your addition, because it's kind of like a cumulative probability, and you're taking 1 minus all of this to get greater than. If you wanted it less than, you'd still add, but you're adding this in here. So it would be equal to the probability that x equals 1 plus the probability that x equals 2. So that's when we use the addition signs most of the time. Addition and subtraction, when we have these greater than or equal to signs. Generally, when they ask you for if the probability equals something, like equals a number, like here, it's that both of them. Well, that's a specific number, 2, both of them. Then you generally multiply your probabilities. And so that's how we got this problem. I know that in this example down here, this is the way that they solved it. And honestly, I still don't understand how they did it this way. And because this is how it would be done. So there you go. I hope that clears things up. And I kind of wrote a summary here of everything as well. And I hope this helps. Thanks.